Assalamualaikum and good evening. Today we will discuss about environmental assessment, water pollution impact focusing on the East Coast Rail Link ECRL. Our dedicated team includes Hamzah Bin Abd Aziz, Hanan Hasina Binti Jahabar Maraikan, Irina Kesuma Binti Ibrahim, Muhammad Akram bin Jailani and myself Suzana Binti Hassan. ECRL is a 665-kilometer electrified railway project that aims to address the economic disparities, improve the transportation efficiency and foster tourism between West Malaysia and the east coast of Peninsular Malaysia. With operational speed of up to 160 km per hour, the journey from Klang Valley to Kota Baru is expected to be completed in just 4 hours. The ECRL is being developed by the Malaysia Rail Link MRLSB in partnership with the China Communications Construction Company CCCC. The CCCC serves as the engineering, procurement, construction and commissioning contractor, while the Ministry of Transport, through the Agensi Pengangkutan Awam Darat, is responsible for overseeing and regulating the project. This timeline outlines the key milestone in the development of the ECRL project, marking significant progress from its initial approval to the anticipated completion. The project represents a major infrastructure initiative that designed to enhance connectivity across Peninsular Malaysia, which potentially foster the economic growth and regional development. In August 2017, the construction officially commenced. By 2019, the project faced a temporary suspension followed by renegotiation that leads to a shorter alignment and reduced costs. In December 2021, the final alignment passing through Selangor is officially confirmed. Late 2025, the first shipment of Golden Electric Multiple Units EMUs and e-locos arrived in Malaysia. Early this year, 2026, ECRL progress reached between 91% to 92%, entering the critical testing and commissioning phase. By December 2026, it is anticipated to complete the phase 1 connecting the Kota Baru and Gombak. By January 2027, expected opening and start of commercial operation for phase 1. December 2027 and January 2028, it is a target date for the completion and operational start of phase 2, linking Gombak to Port Klang.
Hi, I am Hamzah and today I will be presenting on water pollution impact toward the environment. For this slide, this highlights the main water pollution impact during construction, including increased sedimentation, turbidity and change in water quality parameters such as DO, BOD, COD and WKI. These impacts are mainly caused by soil erosion, sediment runoff and construction activity. High sediment levels can reduce water quality, harm aquatic ecosystem and increase downstream flood risk. For the next slide, this slide highlights two additional environmental impacts on the ECRL project, which is groundwater disturbances and biodiversity loss. Tunneling may disrupt groundwater flow and affect soil stability, while sedimentation and pollution can degrade aquatic habitat and reduce biodiversity. River crossing work may also impact fish population and local fishery. Therefore, continuous monitoring is essential to minimize environmental impact. This infographic presents a geospatial environmental assessment of potential water pollution risks along selected ECRL construction location. 4 key assessment areas were identified. First location 1, which is Gombak Genting Tunnel. Tunneling activity near the central forest spine and Sungai Gombak catchment may affect forest stream and groundwater quality. Location 2, Bentung Pahang, earthwork and slope cutting plus high rainfall within Titiwangsa range will increase the risk of erosion and sediment runoff into the Pahang River Basin. Location 3, Dungun Terengganu, bridge and river crossing construction may disrupt riverbed, impacting aquatic habitats and local fishing in Sungai Dungun. Lastly is location 4, which is a Kelantan River Basin. Land clearing work may cause sediment runoff, degrading water quality and increasing flood-related risk. Key environmental concerns include sediment runoff, water quality deterioration and impact on aquatic ecosystem. Continuous monitoring of the SS, stability, WKI, the DO and also biodiversity is recommended throughout the ECRL construction phase.
Hi, I'm Akram. I would like to continue for water pollution impact to social. First, impact is raw water quality degradation caused by excavated soil and wastewater discharge. Domestic activities disrupt due to degradation of raw water, especially communities near to river. And secondly, public health concern which related to sewage and sewage management, wastewater tunneling works and machinery maintenance. Third one is community dissatisfaction. There was some report for river blockage which caused block water flow to existing drain. Fourth, reduced recreational value. It is because of soil erosion and sediment runoff and riverbed disturbance. Then we continue with impact towards economy. First, water pollution cause impact to water treatment costs due to higher pollutant load, which impact to usage of extra chemical and maintenance. Secondly, damage to fisheries and aquaculture due to poor water quality, thus reducing reproduction quantity and affecting local economic activities. And last one, project delay to compliance authority effect. High impact projects require additional environment monitoring costs. Any failure to comply authority compliance require additional costs to rectify as per authority requirement. We continue with geospatial community impact and assessment, where involve Bentong and Temeloh communities and Dungun and Kelantan fishing villages. Each study case is about description to community, water issues, type of affected people, and assessment method.
I'm Hanan Hasina, and also Irina Kesuma will explain in detail about the decision making and mitigation strategy. First, I'm going to explain about the environmental mitigation. We come up with the first mitigation, the nature-based slope stabilization, where the solution we use deep rooting vegetation by combined with the biodegradable geotextile. As when we using the conventional concrete slope, it may destroy the local biodiversity. Thus, when we use the nature-based, it will give the benefits such as stabilize the step slopes, restore the local biodiversity, and also promote the microclimates. Second, we go for the connected fragmented habitats, where the solution we use is dedicated the wildlife eco-viaducts and oversize the aquatics, where it gives the benefit, prevent the habitat fragmentation, and reduce the long-term genetic isolation. Moreover, we also can use the river rehabilitation to enrich the aquatic population inside the river. Thirdly, we go for the advanced round of water treatment, where the solution is deploy the automated dosing units that introduce the eco-friendly polymer, such as the polyacrylamide. This will give the benefit rapid bind ultra-fine clay and lower the TSS and turbidity. Thus, we can ensure that the water treatment follow the DOE standard. And finally, we will go for the fish-friendly river diversions, where they design temporary diversion channel using the geotextile lining, as when we use the conventional channel, it causes the severe bank erosion. Thus, when we go for the temporary river diversion, the fish population can migrate successfully even when they're during construction phase.
This presentation details a framework for economic resilience, utilizing 3 interconnected financial mechanisms to secure long-term livelihoods and mitigate project risk. The first pillar is the Polluter Pays Ecological Compensation Fund. This establishes a legally binding trust fund financed entirely by developers. Mechanistically, it circumvents traditional bureaucratic litigation to provide immediate direct financial aid to fishing communities following unpredictable environmental disruptions. The second pillar introduced life cycle green procurement and carbon accounting. This mechanism mandates low carbon sourcing, specifically recycled steel and blended cement. Strategically, this high-level ESG compliance qualifies the project for international green bonds, effectively reducing our borrowing interest rates. The final pillar focuses on financial and industrial protection through performance bonds. Contractors are legally required to post bonds tied directly to water quality metrics. This enforces strict contractor accountability while guaranteeing rapid relief funds to protect local fisheries from economic collapse. In conclusion, this integrated framework balances environmental accountability with proactive economic safeguards. Next, We have the strategic framework for infrastructure social responsibility, focusing on 4 core pillars designed for community empowerment and public health. First, community-based water monitoring leverage citizen science. Training villages to use water quality testing kits and publishing real-time online dashboards build public trust, mitigates local resistance, and enables rapid anomaly reporting. Second, noise and vibration isolation buffers protect adjacent settlements and schools. Installing acoustic barriers and vibration dampening tracks combats heavy construction and high-speed transit noise, directly safeguarding the psychological well-being and sleep quality of residents. Third, source water protection establishes 5 to 10 km intake protection zones. By integrating real-time control sensors, the framework deploys automated shut-off protocols that flag sudden contaminant spike, eliminating widespread water supply disruptions and costly treatment service outage. Finally, groundwater and aquifer safeguards implement advanced hydrogeological grouting and eco-friendly structural reinforcement. This systematic pre-grouting prevents land subsidence, accidental aquifer punches, and the depletion of local streams. Ultimately, this proactive framework ensures large-scale infrastructure projects successfully balance technical execution with community-first safeguards.
These are the references we use to assess the environmental impact of ECRL on water pollution. That's all from us. Thank you.